Okay, for today, this is a review of basic algebra because we know we're going to use this stuff in the next few units, and if we don't have these down, you're going to have trouble when we hit the stuff. So today's main objectives, we got to write equations from a description. We got to be able to graph a line from a description and find where a couple things intersect where you have two equations. These are all right in the wheelhouse for the ACT too, every single one of these things. All right, we are not going to do the Kahoot right now. We are going to go to these forms of a linear equation. Find this page. Okay. Y equals mx plus b. You've seen that form a bajillion times, right? I hope you got that one memorized. So if I gave you this one, you'd be able to say, oh, I can tell the slope's 2/3 and the y-intercept is 5. So like if I had a graph here, the y-intercept would be at 5 and the slope would be rise 2 and run 3. So it's kind of like that. Does that make sense to you so far? I equals mx plus b form. All right, this form is something that we used to make equations before. And do you see the 2/3 again? Take a wild guess what that is. That's the slope. How about that spot and that spot? It's a point. Is it the point -9, -6? No. Wrong on a couple counts. What point is it going through? We already know the slope is 2/3. What point is that one going through? +6, +9. Why'd you reverse them? Because that's right by the x. And if you know the form of this thing, y minus y sub 1 equals x, m times x minus x sub 1, then you know that this is an x and this is a y, and then there's minuses in the formula, so that means you just take the opposite of both of these numbers. It's not -6 and -9, it's +6 and +9. All right, and then last form that we need you to know is this right here, which is standard form. You get the x's are first and then the y's and then the number. I saw that, Mr. R, stay with me. This is not that easy. All right, this is standard form. Standard form, you have the x's first and then the y's and then the number. It's really handy for a lot of things, one of which is you get A, B, and C. And you know then that they are, that's A, B, and C, the same kind of thing that you could put into the quadratic. No, you actually couldn't. I'm wrong. That could not go in the quadratic formula. All right, the last thing on this standard form I want to remind you is these are all whole numbers. Notice there are not any fractions anywhere. No fractions or decimals. So if you saw this, it's very, very common for a kid to get this. 3x plus 1/2 y is equal to 5. You can't leave it that way. That's not standard form. What do I have to do to make it standard form? Well, what's the problem? It's this fraction. Times everything by what? 2. Times everything by 2. This turns into 6x plus times by 2 here. 2's cancel. 1y equals 5 times 2 is 10. Everything got times by 2. They're all good. All right, moving on. Horizontal and vertical lines. Kids get these mixed up all the time. You're like, is this x equals this or y equals that? Here's my tip for you. Look at this spot right here where it touched. Did it touch x or did it touch y? It touched y. It touched y at what? 2. So therefore, it's y equals 2. Did it even touch the x? So then it can't be x equals something. See what I mean? All right, how about this guy? What did he touch, y or x? Did it touch the y or the x-axis? Y. So there must be y equals whatever it touched. How about this guy down here? What did he touch, x or y? So that must be x equals what? X equals 3. Okay. So these are weird. Why? Because they only have one variable. Instead of saying like x plus 7 equals y minus 2, it's having x and a y in it. It's just got an x or it's just got a y. Yes? Did I say? Oh, you're right. I think I said -2 and didn't write -2. You are correct. Thank you for saying it, especially because it's on the video. All right. That is y equals -2. This one's y equals positive. I can't even see the numbers, they're so tiny. Is it 4? Sounds unbelievable. All right. Okay. I think you got the idea there. It's just the x and the y's that people usually get confused. Parallel and perpendicular lines, I know you know what they are, but when we actually have them in equations, it's important to remember this deal with the slopes. Look at the slope on this one and the slope on that one. They're exactly the same. That's what's going to happen when you have parallel lines. The slopes are the same. How about when they are perpendicular? It's not just reciprocals. It's not just like 3 turns to 1/3. It's opposite reciprocals. Okay, so let's say I got this line, and its slope is rises 1 and runs 3. So y equals 1/3 x plus 7. And it didn't hit plus 7, it had like minus 2. There we go. Do you get that that blue line could possibly be that equation? Because it's got a y-intercept of like negative something down here. And it's not rising much compared to how much it's running. Rise 1, run 3 kind of thing. All right. So then what's perpendicular to that? Negative, and then you flip it. So negative 3. All right. Going really fast, but it's because I want to give you lots of time to be able to work on this stuff. All right, so if I was going to graph these two equations and see if they crossed each other, if I graphed them both on the same graph and saw where they crossed, that would be called the solution to the system of equations. If I graph this one and I graph the other one and they cross right there, then I'm like, oh, well, there's the answer. Okay, so let's see if you can graph these. I want you to graph both of them. I've reminded you a second ago what this and this are. So start at the y-intercept, do the right slope. Here, start at the right point, do the right slope. And then I'd like you to compare. So I don't need you to slide your desks over today, but just turn and compare rows 1 and 2. The kid across from you in row 1 and 2. Rows 3 and 4. Again, the kid straight across from you. Rows 5 and 6. And then you two at the end, you're kind of like row 7. You compare with each other. All right, see if your graphs come out the same. If they don't, talk it through. Perfect. All right, so I asked a kid in class, she said I went down 5 to start with. 1, 2, 3, 4, 5. That's the dot right there. And she said I rose 2 and then went over 3, and there you go. Raise your hand if you were graphing that in the right spot. Okay, good. The other one's different. Who's confident on this other kind that they can put that in the right spot and start? Come on, don't be afraid. Yes, sir. Where do you start? Okay. I agree. The slope is negative, so it's going to kind of go down. But I need to know where to start from. So what point did you start at? All right. Notice he used the opposite of 4. He said negative 4, comma 3. That is the point you go through. So here's negative 4, and here's 3. Right there. Awesome. Okay. And now where do I go from there? The slope you said was important, so what do? Down 2 over 1. Why down 2? Because it's negative 2. Awesome. Goes through like that. Raise your hand if you had that one in the right spot. Okay, cool. If you didn't and you need help, you can always ask the kid next to you again in a second when we have some work time. Or you can ask me after I'm done with the lesson. There'll be some time where you can ask one-on-one questions. Okay. Now, what's different now? This is a description of the line they want. But it's not telling you what form to use. You got to be smart enough to know which of those two forms is better for this. Hint, one's called slope-intercept. If they give you a slope and an intercept, do that one. One's called point-slope form. If they've given you a point and told you how to get the slope, then you should probably do point-slope form. Remember which one's which? That's point-slope because it's got the point here and the slope there. And the other one, y equals mx plus b, that's slope-intercept. All right, see if you got that well enough by trying these two. And this one says, without putting it in y equals mx plus b form, interesting, maybe you should find the x-intercept and the y-intercept. Do you get what I'm saying? Because the x-intercept is where y equals 0, and the y-intercept is where x equals 0. That would be a way you could do it, option C in my class, I've always said you can always make an XY chart. XY chart is your best friend in graphing. So you could do an XY chart and say, what if I stuck in X is 0? Then what would Y have to be? Y would have to be 6. I know the 0.06 is on the line. You know what I'm saying? You can do it that way. And then option D is just solve it for Y. And that is putting it in Y equals mx plus b form. But there's a better way than that. So you have lots of choices. Graph both of those. I'll pause for a second while you give those a try. And for the few kids that were kind of looking at this going, I don't know how to do this. Perpendicular to this is telling you the slope. They've told you the slope, and they've told you the y-intercept. All right, I'll pause again while you work it. I can tell you guys they're done, at least with that first one. So let's see how you're supposed to do that. Perpendicular to this, you should have said not 1/3. Actually, first one, not negative 1/3, but positive 1/3. If you knew that the slope, m, should be positive 1/3, you've got that whole negative reciprocal thing down. Raise your hand if you had that part right. Okay, good. Then the other part is the y-intercept, which is 0, -5. There should be a comma in there. Sorry about the little thingy, but 0, -5, 1, 2, 3, 4, 5. So it starts there. And how do I have a slope of 1/3? I rise 1 and I run 3. Rise 1, run 3. Up 1, over 3. All right, and then put a line through that. Cool. Okay, how about the other one? It says without putting in y equals mx plus b form. Well, if they forced me to do that, I'd find a whole bunch of points on XY chart. Otherwise, I'd solve for y, which is what they said not to do. So what else is there? Yes?
Can you put like 0 in for x and 0 for y?
Yes, you can put in 0 for x, and that's really what you're doing is this. Putting in 0 for x and seeing what y comes out to be. Okay? If I put in 0 for x, what do you get? That means 2y equals 12, and therefore y must equal 6. And if you put in 0 for y, it doesn't work out quite as nice. You get how 5x equals 12 is not going to come out super nice, but it still works. What would it be? If I stick in 0 for y, x would have to be 12/5 or 5/12? Well, it's 5x equals 12. X equals 12/5, and that is the same as 2 and something. Okay, so I'm going to call it 12/5, also known as 2 point, well, it'd be 2 and 2/5 would be about 2.4 or so. So 2.4 comma 0 is about there. And the other point we had was 0 comma 6. Hey, if I connect these two and it's a straight line, do you get it past the line? Connect the dots. Every other point would have to be on that line somewhere. See what I mean? All right, so that would absolutely work. Is there another way? Of course there's another way. There's a million ways to graph this thing. One way is type it into Desmos, and you got an app called Desmos, right? And that would have graphed it, but we're not going to allow Desmos on the test. So, yes? You absolutely could find the slope, but do you get... Okay, if we do that, we're breaking this little thing without putting it in mx plus b form. Hold on just a second. How are you getting the whole slope is 5/2 thing?
Oh, I plugged in like different numbers for x and y, and then I realized that the equation was 5x plus y.
All right. Really what you're doing is this. I'm going to subtract 5x from both sides of the equation. And watch what starts to happen here. 2y equals negative 5x plus 12. And then I'm going to divide everything by 2. Y equals negative 5/2 x. Divide everything by 2 plus 6. There it is. That's how you can get that slope you just said. So instead of just finding points, and you could just solve it for y, but that's what they said not to do. Well, again, I'm not that concerned about it says without putting in that form. I'm okay with you not obeying that unless it was a test. That's a great way to do it. Solve it for y. Find the slope like you said. Or just if you find the slope and you know the slope was negative 5/2, what other form could you have used? If you knew that m was negative 5/2, what other form could you have used? Yeah. Well, y minus y1 equals m times x minus x1. That's point slope. And then I can put the slope here. And then I just have to find a point. Any point. Do you get we know a point? We know a point that's on this. If nothing else, you can find a point by saying, what if I stuck in 0 here? What would I get? You know, from the XY chart? You see how I'm coming back to the XY chart? They're so powerful. All right, so 2 times 0 and 2 times 6 would make the 12. 0, comma 6 works, right? So that's my point. That point and that slope can go into point slope to get your final equation. Y minus, what's the y of this? 6 equals m, negative 5 halves, times x minus, what's the x of this point? 0. And there we go. All right. So there's more than one way you could do this. For some of you guys, I don't know if your teachers emphasize the XY chart as much as I did. You know why I do that? Because I can solve crazy equations. I don't even know what they look like, and I can find out what their answer is by just making an XY chart. What if I said to find where sine of x is equal to 1/2? And you're like, I don't even know what you're talking about. Guess what? You can find points for your XY chart by just sticking in numbers with your calculator on the x and seeing what you get. There's so many great ways to use the XY chart on weird equations. You don't need it for this because you know it has a y-intercept of negative 12 and a slope of 6. But what if it was this? Again, if I want to, I can make an XY chart. What if it's like this, though? 1 over x squared equals 32. I don't know what that looks like, but an XY chart could figure it out. Just stick in numbers for x, figure out. In fact, I can even throw in a y over there, too. All right, enough of preaching on the XY chart. They're really, really handy. If you haven't figured it out, I hope you will, because I encourage my kids to know both ways. That way you try it the other way, and then you just take a few points off the XY chart in, and if they work, whew, then you know you got it right. All right, last thing. Do you get that's the obvious important spot on this whole graph? It's where they cross. All right. Then, if you graph two lines, you just have to find where they cross. It's called the point of intersection. All right. Now, there's a way to do that with a calculator, which we're going to show you on Friday. But for now, we're just going to tell you other ways that you can find the point of intersection of the two lines. One way is called substitution, and another way is called elimination. I think substitution is probably the easier of the two, but it's kind of good to have both tools in your tool bag. In other words, substitution can always work, but sometimes it's really messy. It's kind of like this. If I was a carpenter, I could cut a hole with a saw. Would it be the right tool for the job? No. It'd be really a pain. Could you actually bust a hole into something with a hammer and a chisel maybe? And you could probably make a hole with a hammer and a chisel, but that'd be so stupid compared to using a drill. There's some tools that are the right tool for the job. In math, you can always use substitution, but sometimes it's about as dumb as using a hammer to make a hole. You can do it, but it's like, that's just so much easier to use a drill. My point, it's good to know both ways. And some of you are guys, I get substitution. I don't need the other way. Okay, but it's be good to have that tool in your brain to know elimination too. All right, here's substitution. It says y equals x minus 2. That means I can put x minus 2 where y is. See, here's a y. What do we say y was equal to? X minus 2. There's an equation that you can solve. And then you're done. Substitution's pretty easy. I'll say that again. If I'm doing substitution, and it's already solved for y, then if y equals this, I can put this right there, and it'll be an equation you could solve. Go ahead, solve that equation, and finish it too, because I don't want you to just know x equals like 2. I need to know what y equals also. But once you know x is 2, you can just stick it there and say, oh, y equals 0. I'm not saying it is x equals 2. Put this there, substitute, solve. I'm going to pause for a second while you try that one. it should look like this. X minus 2 equals negative, I changed it to 1/2 x plus 3. Know why I did this? Because I have taught my students how to clear those fractions. Do you know how to get rid of that fraction so it's not there anymore? Times everything by what? 2. Why is that smart? To times everything by 2. One of your calculus teachers that you're going to hit a couple of years from now swears by this method in calculus. They use it all the time in calculus. If you have a fraction, just multiply by that denominator, fixes the problem, doesn't have fractions anymore. 2x minus 4 equals, what is 2 times negative 1/2? 2's cancel and you have what? Negative x or negative 1x plus 6. And now if you can't solve that one, I'm scared for you because that's basic algebra. Solve from there. See what you get for x. You got variables on both sides. If you were lost up till this moment, just take this and solve it right now, please. And then check with the kid next to you and see if you get the same x equals. Okay, here's what you should have done. To get rid of the smaller of the two x's, there is more than one way to do this, but the easy way, add x to both sides. That makes this 3x minus 4 equals 6. I'm not saying that's the only way, but it's a way. I always get rid of the smaller of the two x's, and you get negative x is the smaller of the two x's. All right, then I'm going to add 4 to both sides. 3x equals 6 plus 4 is 10. X equals 10 thirds. Raise your hand if you had that one right. Awesome. How do I finish the deal? I have x equals 10 thirds, but that's not a point. That's 10 thirds comma something, but I don't know what. Put it back in. Negative 10 thirds? No, 10 thirds. 10 thirds goes here. Here. Or here. But that one's icky because it's got the fraction, so I don't like that one. Whatever 10 thirds minus 2 is, that's a bit of a pain. It involves common denominators. Times this by 3, times that by 3, and all of a sudden it's 10 thirds minus 6 thirds, which would be 4 thirds. All right, I know that was icky. That was the icky one because it had fractions in it. But here in honors, that's the kind of thing that happens in honors versus regulars. You got to be able to handle fractions. All right, so pausing. It would probably be smart for me to show you what elimination is. All right, watch. If I simply add straight down, I add these, I add those, and I add these, it's legal to do that. You might think, why is it legal to do that? Do you agree that if I wanted to add, just look at this equation. If I wanted to add 1 to both sides, do you get that would be legal? If I wanted to do that? You can add anything you want as long as you do it to both sides, right? So I'm going to add 1 on that side, and since 1 is equal to all that, I'm going to add that to the left side. You get how this is equal to this, so therefore they're the same thing. Therefore, I'm really adding the same thing to this side as I am to that side. They just look different because 1 is equal to all that. All right, so that's my help you understand why you can do this deal. But if you just really want to add them, that's all you really have to do. 7 plus 1 is 8. Negative y plus 3y is equal to what? 2y. And then 3 plus 2 is 5x. But why didn't this work then? How do I know it didn't work? Because nothing eliminated. Nothing got eliminated. It's called elimination. Either the x or the y should have got eliminated. Who remembers how to do this? I had to do something first before I add them straight down. Yes? Why are you multiplying everything by 3? Perfect. You see how those will cancel each other when I add it straight down now? All right. So this is now 9x plus 2x makes 11x. This is 3y, or negative 3y and positive 3y, which cancels. And 21 plus 1 makes 22. Awesome. X must equal 2. See how quick that is if you know how to do it? That's called elimination. That's a review of a lot of regular algebra. And we're down to about 3 minutes left. So sorry I'm not going to answer your question right now. I got to keep moving. I want you to open up that Schoology quiz and we're going to get it started together. Okay, so here's how it looks. Number 1, it wants the x-intercept. Enter as a coordinate pair without commas. Okay. So if I want the x-intercept of this thing, it's where y equals 0. I'm going to stick in a 0 right here and solve that little equation. So 3x minus 0, which is just 3x, equals 18. What's x got to equal? 6. How do you enter as a coordinate pair without commas? Ugh. Well, it's x equals 6. That's a coordinate pair without commas. 6, comma 0 is what I would have wanted you to put, except it says without commas. All right? So I'm thinking they mean 6, comma 0. But this is one of those moments where I can and will go to edit the question so I can see what their answers are listed as. And there they have it with commas. So I guess I'm trying to figure out what they meant. Those are the answers for blank 1, 2, and 3. Okay, I think you're right. When they said without commas, I bet they meant without spaces. All right. So the y-intercept, it's got three blanks. The slope, the y-intercept, and the x-intercept. All right, so the slope of this thing, you'd have solved it for y, and you'd have found the slope, and you put it there, and the slope was 1/3. The x-intercept and the y-intercept, what we figured out right here, this was the x-intercept, which is where y is 0. So, yeah, sorry about the whole without commas thing. We'll get that fixed. All right, have a great day.